with mainly linear equations, which are in the form of y equals mx plus b. But now we're going to talk about quadratic equations, which are in the form of y equals ax squared plus bx plus c. So this is a second degree polynomial where a, b, and c are your coefficients and a cannot equal 0. If a equals 0, that would make your x squared go to 0 and you would just be left with a linear equation. So we're looking at anything with a quadratic, which is a squared term. And what we're going to do with these is we're going to solve them just like we did linear equations. There's a couple different methods, but when you're asked to solve in a quadratic, you always want to have it set equal to 0. So ax squared plus bx plus c needs to equal 0, which basically means your y is equal to 0. This is called standard form for a quadratic. And again, if you're going to solve a quadratic, you want to put it in standard form, and then you can use multiple different methods to figure out what x is. One more thing before we actually do some examples. If you're asked to solve, you can be asked in numerous ways. It could simply say just solve it, but if it says find the x-intercepts, you're also solving it. It could say find the roots. It could say find the solutions. Or you could be asked to find the zeros. All of those things are asking you to do the same thing. Your x-intercepts, remember from previous sections, x-intercepts are where y equals 0, which is what we've set y equal to here. And then root solutions and zeros are just different ways to say the same thing. So the first method we're going to use is factoring. And if our leading coefficient is 1, these are the rules or the steps to follow to factor. First of all, your leading coefficient is a, so a has to equal 1 for this to work. So first of all, you're going to find two numbers whose product equals c and their sum equals b. You're going to use those two numbers to write two linear factors, and then you're going to solve using the zero product property. And the zero product property is simply if you have the product of two things that equals 0, then either A would equal 0 or B would equal 0. That's the zero product property. So what we're going to do is we're going to take our two linear factors and set them equal to 0 to find x. So hopefully this will make more sense when we do a couple examples. So let's look at this first example. It says factor and solve. So we're going to look at, first of all, let's identify what A, B, and C are. If you have a squared plus bx, ax squared plus bx plus c equals 0, our a is the coefficient of the x squared term, b is the coefficient of our x term, and c is our constant. So here a equals 1, b equals -2, and c equals -8. So following the steps from above, I'm looking at -8, and I want to know the product of what two numbers will add together to give me -2. So first of all, let's break the -8 up into all of its products. So you could have 1 times -8, or you could have -1 times 8 to get -8, or you could have 2 times -4, or -2 times 4. So looking at those, we need to figure out which one adds up to be -2. This one does not. This one does not. 2 plus -4 will give you -2, and then -2 plus 4 would give you a +2. So the one that's going to work for us is 2 times -4. That'll give us our -8, and if we add them, that'll give us our -2. So we're going to use that to write linear factors. So we've got x plus 2 because 2 is positive, and x minus 4 because 4 is negative. Those are our two linear factors. Now, if you want to check to make sure you factored right, you're going to FOIL your two linear factors. So I've got x plus 2 and x minus 4. And when I say FOIL, that means I'm multiplying the two binomials together. The FOIL is just an acronym to say F is for you multiply the first two terms together. So x times x is x squared. O is for the outside terms. So I've got x times -4, which will give me a -4x. I is for the inside terms, which will be plus 2x. And then L is for the last terms of each one, which would be the 2 times the -4, which would be -8. So if you combine like terms, which are your two middle terms, you get x squared minus 2x minus 8, which is what we started with. So we did factor correctly. So we factored. Now we need to solve. This is where we use the zero product property. I'm going to take each linear term and set it equal to 0. So I've got x plus 2 equals 0 and x minus 4 equals 0. And then solve those for x. So I've got x equals -2. And then this one I'm going to add 4 to both sides, and that gives me x equals +4. So my x-intercepts or my roots or my solutions or my zeros are -2 and 4. Now let's look at an example where your leading coefficient is not 1. So I've got 6x squared minus 3x equals 0. Now notice here that you don't have a constant term. So each term has an x with it. So if at all possible, check and see if you can pull out a greatest common factor, which in this case, what can I pull out or divide by both of those by? And if I look at it, I can definitely pull an x out of each term, but even more than that, 6 and 3 are both divisible by 3, so I can pull out a 3x. And if I divide the first term by 3x, that'll give me 2x. And if I divide 3x by 3x, that'll give me 1. So here I don't even have to factor it. I've just pulled out the greatest common factor, which was 3x. And notice if you want to check that, if you distribute the 3x back in there, you get 6x squared minus 3x, which is what you originally started with. So now I've factored it. I'm still going to set each term equal to 0. So this in itself is a term. And then the 2x minus 1 is also another linear factor. So here, anytime you have 3 times x equals 0 or any constant, if you just divide by that constant, 0 divided by any number is still 0. And then over here, I'm going to add 1, which will give me 2x equals 1, and then divide by 2. So x equals 1/2. So my two solutions are x equals 0 and x equals 1/2. So when you start a problem, make sure you look carefully at what you're dealing with and see if you can pull out something first, your greatest common factor, instead of trying to factor it into two linear factors. Okay, the next one also does not have a leading coefficient of 1. It's also not set equal to 0. So that's what you're going to do first, is I'm going to subtract 3 from both sides so that I'm set equal to 0. So I've got 2x squared plus 9x plus 4 equals 0. So now I'm in standard form. My only problem is a isn't 1, so it's not quite as easy as that very first example, but there's still a method to this, and that is you're going to take the product of a and c, which is going to be 8, and I'm going to write the factors of 8. So I'm going to have 1 and 8 and 2 and 4. So now again, you're going to say which one of those add up to give you your b or your middle term. And it's obviously going to be the 1 times the 8. Okay? So here, this is a little different. I'm going to rewrite everything, but I'm going to unadd the middle term into the two factors that I found. So I'm going to have plus 1x plus 8x. And then I'm going to bring my 4 down. Okay, so the only thing I've done here is I've taken the factor or the product of 2 and 4, which is 8, and found the factors of it, and then found which one of those add up to be b, and then I've unadded. Now I'm going to group the first two terms and the last two terms and look for my greatest common factor like I did up here. So here I've got 2x squared plus 1x. Well, the only thing I can pull out of there is an x. So I've got 2x plus 1. And then in the next set, I can pull out a 4, a positive 4, which will, if I divide through by 4, gives me 2x plus 1. Now notice that what's left is the same on both. That's going to be one of my linear factors. And the other linear factor will be what's left on the outsides. So my other linear factor is going to be x plus 4. And that all equals 0. Should have that up there too. So if you check that by foiling, you're going to have first is going to give me the 2x squared. Outside will give me 8x. Inside will give me 1x. And last will give me 4. And the middle two terms will combine together to give you 9x plus 4. So that's my original equation. So that's factored form. Those are my linear factors. And now you're going to solve those by setting them each equal to 0. So here when I subtract 1 and divide by 2, let me do it separately. Just running out of room. I'm going to subtract 1. So I've got 2x equals negative 1. And then divide by 2 will give me x equals, I'm going to pull it over here, negative 1/2. And then this one, when I subtract 4 from both sides, will give me x equals negative 4. So my two solutions to that are negative 1/2 and negative 4. So those are some examples of factoring when your equations are different in different forms. There's more methods for solving for a quadratic, but we'll cover those in the next video.